Okay, hi friends. So in this video I'm going to talk about the difference quotient, but I'm not just going to show you the formula for it. So I'm actually going to explain what it is, because the difference quotient actually leads us to kind of something that is a bit of a conundrum, if you will, in mathematics, and it opens up a very exciting door for the world of calculus eventually. This video is meant for like pre-calc students, so we're just going to get into this. All right, so I can't talk about the difference quotient without explaining to you what is a secant line. So to create a secant line, what we're going to do is we just draw some random graph. We're going to call this graph f of x. Just it's whatever, okay? Now, on that graph, you can choose any 2 points that you want. I'm going to label them P and Q. And if I connect those 2 random points that I just chose and connect them, that makes what is known as a secant line. So that's all a secant line is. It's a pretty simple concept. Draw some curve, choose 2 points, connect them, secant line. Now, we have a very specific way that we want to think about the secant line. We think about the secant line actually a little bit in terms of like distance from this point to this point, okay? So where I'm going to start with this is I choose the leftmost point, P, and I just label that as x. And I want to keep everything in terms of x and f of x. So, you know, sometimes when we talk about coordinates, we talk about them as x, y. We're going to make a little shift in how we think about this. Instead of calling this x, y, we're going to call this x and f of x. So think of this, we plug this into the function. So here's x on the x-axis, and here's f of x on the y-axis. So that's where that is. Now, we started with P as the leftmost point. And to get to Q, if I want to think about how these 2 points relate to each other in terms of distances, a shift of how I think about this is instead of just labeling this as some other random coordinates, I think of this as I go from x and then I choose some distance h to get to my next point. So I start at x, I choose some distance h, and that's what gets me to Q. Okay? So the question is, using this h and then this x, how can I label the coordinates of Q with the information that I've been given? So the x coordinate of Q can be found if we take whatever this is plus h, right? So the x coordinate of Q is just x plus h. So it's wherever we started with x, add that distance h. And then, trying to keep everything in terms of f of x, all I have to do is plug in this x plus h. And so now, here's where I'm at on the y-axis, f of x plus h. So just to be clear, so we think of the point Q as x plus h, f of x plus h. So it's very important that you frame the h as a distance, okay? So we're changing the way that we kind of think about points. We're thinking about, we want to really track how they are in the distance between one another. Okay, so now I'm going to ask you, what is the slope of our line PQ? How do I figure that out? So we can use the good old slope formula to do this. Slope formula, it's like an algebra 1 thing, right? So I have 2 points. This is the general slope formula. It's not for this right now, but right, just in general. So if I have 2 points, x1, y1, x2, y2, this is how I calculate slope. Okay, so we know that. Now, I want to take this and now think about it in terms of what I've drawn here and the new way that I thought about my points. So I'm using x and f of x, right? And then x plus h and f of x plus h. So these are the 2 points that I'm going to plug into the slope formula. So the way that I'm going to think about this is this one will be my x1, y1. This one will be my x2, y2. Now, I want you to engage with this a little bit because I've kind of thrown a lot at you. So what I want you to do is I think you should just take a second to pause the video and calculate now using these points that we've created, x and f of x and x plus h and f of x plus h. Use those to find the slope. So pause here, just take a second to calculate it and see what you get, just so that you can kind of get involved in this explanation a little. Okay, so if I plug in these points into the slope formula, what I get is f of x plus h minus f of x. And then in the bottom, so x plus h minus x. So there's me plugging these points into the slope formula. And you can see, right, that the x's, these drop out. And so this whole thing simplifies then to f of x plus h minus f of x over h. And so this formula describes the slope of the secant line. And at the same time, this formula is what we call the difference quotient. Okay? Now, believe it or not, the secant line actually is kind of an important concept in mathematics, because the slope of a secant line represents the average rate of change over some interval. So that might not mean a lot at the moment, but if you were trying to figure out, an average speed or something, so if I were to come back to this idea here, let's say that I was going really fast and now maybe I'm coming down to a slowdown. And if I wanted to know what was my average speed in a period of time from, say, this point to this point, I would calculate the slope of this secant line, and that would tell me that average speed I had as I was braking. We could think of it like that. So it's kind of an important concept. And so just to review that one more time, so just to simplify everything that we're looking at here. So we really defined all of this in terms of an x and a distance h, right? And then we used f of x to kind of help us out with this. So this was the situation that we had. All right, so here's my next question. What does it mean? Like, what is the deal with the secant line if this distance h here, what if we make it smaller? What does that indicate? All right, so we got to think about this. If I move where my x is, if I move it in a little bit. So think about what's happening with this average. When my x was, let's say, where we started, this average is, this doesn't tell you a lot about, what happened at any particular moment, right? Like, so maybe I was going, if we think about this in terms of like speed or something, maybe I was going really fast and now I'm like almost stopped. So the average could have been something, in between, but it doesn't really tell you how fast or how slow you're going. Now, if I start to bring this x in a little bit, like you see here, notice what happens to the secant line. So just keep watching it for a second, okay? So I'm going to bring it in one more time. So as I continue to bring this x closer and closer, this average starts to align, and it will do this all the time with any graph. When you start making this distance small enough, the average is going to start to kind of line up closer and closer to your actual curve. This always happens if you start to make this distance small enough. So if I continue to make this distance smaller, now it looks like this secant line almost matches like what the graph is, right? So that's kind of interesting. We went from having like this large average, but if we really shrink it down, we almost are now getting maybe what the speed is, or, I'm thinking of this in terms of speeds, what the speed is at a moment in time from a graph. So that's something that we haven't been able to do in the past with just plain old algebra. Whenever we talk about in algebra speed, we always talk about it from like, you're just going this constant speed. And this is an interesting concept because now I could speed up and slow down, and I could figure out a little bit about that speed in a moment in time just by bringing these 2 points closer together. So if I continue to bring them closer together, so think about now what's happening to h. What if I bring these 2 points in so close that they're like right next to each other? It's like at this point, it's almost like you're approximating the slope for a moment in time on your graph. So slope is usually a concept that we only think of in terms of lines. And yet now, if we make these points close enough, it's almost like you can get slope at a moment in time. And that's kind of an interesting idea. Now, let's say that I shove these points so close together that they are basically on top of one another. So now I've got P and Q. I can't tell the difference between them. So I've got X and X plus H. They're like literally on top of one another. I can't write them on top or it's going to look confusing. So if I move these points so close together, that probably will get me to what the slope is at a moment in time. But there's a conundrum here. What would h equal if I slid these points closer together? So remember, h stands for that distance between the 2 points. So what must h equal? Well, if I slide them this close together, the distance between them is non-existent, right? The distance becomes 0. So h equals 0. And this creates a problem. H equals 0. If I plug h equals 0 into this difference quotient, we get a 0 in the denominator, right? And that's bad. So, all right, I have h equals 0. I've got a problem. But this is a little bit of a conundrum because clearly I can slide the points next to each other. I can make this happen. It's clearly possible to do this on a graph, but just in the way that we're thinking about the difference quotient, there's like this mathematical anomaly. And so we have a mathematical problem, but not necessarily a graphical problem. So what's the answer to this? What does this mean? Well, the answer to this actually is that we need more math to explain this. And this is actually where calculus kind of starts in some ways, is it's trying to answer, why is it that I can slide these points closer together and make that distance 0, but that creates a mathematical problem? How do I resolve those two things? That's something that you resolve in calculus. So for pre-calculus, what we're trying to do is we want to just get good at working with a difference quotient, which, you know, like we said, is like the slope of a secant line. So we're just trying to like dip our toe into understanding this. And so the difference quotient, we just want to be able to calculate it and practice it so that when you move on to calculus, you're not tripped up on that calculation. So what I'm going to do now is I'm going to show you how to calculate the difference quotient just for a couple different functions. So you're going to be given a function, and so you're probably going to want to write the difference quotient down every time you do this. So let me just write it down. Okay, so boom, there it is. All right, so to calculate the difference quotient, I like to do it all at once, but I like to color code it so I can kind of follow what I'm doing. So the first thing that I want to do is I want to calculate, or I want to figure out what is f of x plus h. So I think this kind of throws people off a little bit the first few times they do this. Like, what does it mean to calculate this? So the deal with the function, right, is that what this notation means is where you have an x, replace it with whatever I tell you to replace it with. So if I'm telling you now to calculate f of x plus h, I'm telling you to take x plus h and to plug it in where you see an x. So I see an x here. Therefore, I'm going to change that x to x plus h. So I'm going to write this in pink just so you can track kind of what I'm doing. So you see how I change the x to an x plus h? That's the first thing that I want to do. So that was the first part of this. And now the second part of this is to calculate, or to just write down f of x. So that's literally now going and repeating 4x plus 5. So I'm just going to write that down. 4x plus 5. And so lo and behold, now we have the top part of this calculation, and all of this is divided by h. Okay, so this is always the first thing you want to do with a difference quotient, is just figure out these parts. And then the next thing that you want to do is calculate what is the top. So you just have to work it out now to the best of your ability and just, you know, do whatever the math is telling you to do. So in this case, I need to distribute the 4. I need to distribute the minus sign. So let's go ahead and do that. So this becomes 4x plus 4h plus 5 minus 4x minus 5, all of that divided by h. So now that I've got that all written out, what can I do on top? Well, I see here that the 5's actually cancel out, as do the 4x's. So what I'm left with now is 4h over h. And so now you're saying, oh, well, the h's also cancel out. And so my difference quotient is just equal to 4. Okay, so now what I want to do is I just want to take a moment to like, does this make sense? Is it 4? Can we tell? Yes, we can totally tell. So first of all, f of x equals 4x plus 5. What type of graph is this? This is a line, right? So if you think about it then, with a secant line, normally I'm taking 2 random points, right, and then I'm calculating the slope in between them. But if I'm using a line, if I take 2 random points on the line, well, you're just going to get the slope, right? A line has an actual slope. It's not like a curve that, you know, normally a curve is like this, and so we can't say it has some standard slope. But a line does have a slope. So the fact that I got 4 as my difference quotient makes sense because this represents the slope of a secant line, or how to get to the slope of a secant line. It's a little more nuanced than that, but for now, we'll just say it represents the slope of how to get to the slope of a secant line. And so finding 4, that is the slope of the line. So yeah, intuitively, this makes sense. Now, let's take a look at another example here, x squared minus 1. Now, this will not have a slope, right? It's a parabola, so it doesn't have some standard slope. So the difference quotient is going to be something a little weirder this time. So first, let's just write the difference quotient down. And now we'll take pieces. So what I want you to do is I want you to write down what you think f of x plus h is. Just write down that part for a moment, engage a little bit with this video, and then if you think you've got it, hit play. So I need to take where x plus h is, or where x is, and replace it with x plus h. So right here, I'm going to replace this x with x plus h squared minus 1. So I literally rewrote the expression with x plus h squared minus 1. Okay, oops. All right, so next, now I want to move on to the next part of this, which is to subtract f of x. So maybe what you want to do here is to write out the rest of this calculation and simplify it how you think it should be done, and then hit play. So I'm going to subtract off x squared minus 1, all of this divided by h. Okay, so remember what I told you. So you have to now just kind of use your noggin to figure out what else can you do. So in this particular example, x plus h squared, this has to be multiplied out, because remember, this means x plus h times x plus h. That is what that means. So if I work that out, that becomes x squared plus 2xh plus h squared minus 1 minus x squared plus 1, all of that over h. So if you didn't get that, so just remember that kind of going forward, like anything can kind of happen with these difference quotients, so you just want to kind of stay on your toes and watch out for what algebra you need to use. Okay, now the next thing is, what can I cancel out? So these x's cancel out, and also these 1's cancel out. So my difference quotient now is just 2xh plus h squared over h. So to simplify this a little bit farther, I'm going to factor h out of the top, which is my preferred way to cancel things, because now I can see that these h's cancel. And so my difference quotient will be 2x plus h. So what this means then is, if I have a starting point and I know that distance between that point and the next point, I can plug in the x coordinate from my starting point and the distance I want to go, and this will give me the slope of the secant line. So that is kind of the nuance of that formula. So I have another video with more examples of the difference quotient, some like harder ones. So I'll drop a link to that in the description if you want to see a few more. And otherwise, that's going to bring us to the end of this video. So that is what the difference quotient is. It is a door to calculus. So I hope that one day you walk through that door and discover the mystical, magical land of calculus. And okay, so I will catch you guys in another video. Thanks for watching.